Question number 5 says integral of -1 to 1 e power x dx is equal to what? Now let's take a look at this integral over here. Once again, we'll begin with the form, the exact version of definite integral as limit as sum. So integral a to b fx dx can be written as limit n tends to infinity b minus a upon n. In the square bracket you have f of a plus f of a plus h plus dot 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 f of a plus n minus 1 h is what I'll have over here. Brackets closed. This is what you have. Is that okay? Yes, that looks pretty much okay. Now, in this particular integral, if you observe, by comparison with this expression, if you observe a is equal to -1, b is equal to 1, f of x is equal to e power x. This is something which you can directly see using the left hand side. For the right hand side, I need h, which is b minus a upon n, which will be equal to 1 minus of -1, that becomes 2 upon n. This is what you'll have. Is that okay? Yeah, that looks pretty much okay. That's pretty simple up till now. Now, once I'm clear with this much, what next? So therefore, this integral I, which is -1 to 1 e power x dx will be equal to what? This will be equal to limit n tends to infinity b minus a upon n, which is 2 upon n. In the square bracket, I have f of a. F of a will become f of -1 plus f of a plus h minus 1 plus h plus simply keep on adding f of a plus n minus 1 h. This is what you have. Is that okay? Yes? Yes. So this now becomes equal to what? Limit n tends to infinity. Okay. 2 by n remains as it is. Okay. And f of -1. Now f of -1 is equal to what? F of -1 will be e power -1 in the bracket plus e power -1 plus h is what it'll have plus e power -1 plus 2h is what I'll have plus dot dot dot, and similarly you'll have e power -1 plus n minus 1 h over here. This is what you'll have. Take a look at this expression, replacing f of -1 with e power -1, f of this using f of x equal to e power x is what you have done. Now our target is to simplify this somehow. This is 2 by n. So this becomes limit n tends to infinity. 2 by n is okay. In the square brackets, what I observe is e power -1 times, what is this? If you take a look at this carefully, e power -1, for that matter, e power -1 is 1 upon e, but this here can be written as e power -1 times e power h plus e power -1 times e power 2h plus dot 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 e power -1 dot e power n minus 1 h is what I observe over here. And now you can think of taking something common. Let's move on to the next step after this. This tells me I is equal to limit n tends to infinity. 2 by n remains as it is. 2 by n remains as it is, yes. And I can take out e power -1, which is 1 by e common. In the bracket, what do I have? E power -1 taking out common, this will leave 1 by 1. This will be e power h, e power 2h plus dot 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 e power n minus 1 h. Pretty interesting. This is nothing but a geometric progression, right? First term is 1, common ratio if you can observe is e power h. So sum is very simple. This is limit n tends to infinity 2 by n 1 by e times this summation will be first term times common ratio power number of terms. How many terms are there? Total n terms are there. -1 upon common ratio -1 is what I observe. Can you observe that carefully? Yes, this is what you get. Okay, this is in the square brackets. Now let us simplify this further. Limit n tends to infinity 1 by e or 2 by e is okay. 1 by n will go inside. And what do we have in the numerator? We have e power nh. Now e power nh is nothing but e power 2 minus 1 upon e power h, which is e power 2 by n minus 1 in the denominator over here. Now observe, this e power 2 by n goes to, because n tends to infinity, this goes to 0. So e power 0 minus 1 upon 0 is what is required for evaluating the limit. So limit n tends to infinity, let it remain as it is. This 2 by n, okay, e square minus 1 is also brought out, and this 2 by n is given to this square bracket. This becomes 2 by n upon e power 2 by n minus 1. Now let's take a look at this limit. Limit n tends to infinity. Now a result which I recall from the concepts of limits is this: limit h tends to x tends to 0. Instead of h, let's use the actual x. E power x minus 1 upon x is equal to what? This is equal to this, right? So if n tends to infinity, 2 by n tends to 0. E power 0 minus 1 upon 0. This is e power tending to 0 minus 1 upon tending to 0. E power tending to 0 minus 1 upon tending to 0. Oh, this is the reciprocal of this. Yes, doesn't make a difference. We take the reciprocal of this, and that limit will be 1. This will be 1 by e times e square minus 1 times this will be 1. Limiting value will be 1 over here using this. And this here is e square upon e, which is e minus 1 upon e. That is the required answer for this particular question. As you can see, this complete solution over here. I'll get a slide for you to take a look, and that is all that you have in this question